Okay, so there we go. So x greater than 7. X greater than 7. I'll just do it right here, and then we'll grab the right option. So x greater than 7. Oh, we're supposed to be at break time, aren't we? What are we going to do? We're going to take the test, huh? Oh, yeah. We need to... Wow. All right, let me finish this up, then we'll take our break and come back and take a test. Is that right? Because we got to take the test from 9 to 10, huh? We're done at 10, aren't we? Yeah, all right. So, yeah, I got to finish this quick, and we need a break, and then we'll take our test. All right. So, just a couple minutes. This should be an easy section. So, x greater than 7. Yeah, x is on the wide side. Remember how the symbol works? When you're on the wide side instead of the narrow side, you're greater. So, this is x greater than 7. So, if you put 7 here, x is going to be shaded to the right. Because the shading, whenever you shade on a number line, you're shading the x. You're shading where x is. X is greater. Greater numbers like 8, 9, 10, they're to the right of 7, aren't they? Here's 7. And greater numbers are to the right. Now, oh, they also have the open dot, closed dot thing. Do you know about that? When it says x greater than 7, that would be numbers like 7.1, 8, or 7.6. Anything bigger than 7, but not 7 itself. If they put an equals bar, then you could be 7 also. That would mean greater than or equal. That's the bottom of an equal sign, isn't it? So that would mean greater than or equal to 7. You could be right on 7. But if they don't put the equals bar, which they did not, then you can only be greater than 7. You can be 7.1. You can be 7.0001 even. But you can't be 7 right on the money, can you? You got to be greater than 7. So how do you indicate on a number line that you cannot be right on 7? You put an open dot. It's like you drilled it out there. Just you drilled out that hole. You can't be right on the 7. There's a hole there. But you can be to the right of 7. So here it is. You see how they have the open dot right there at 7, and they shade to the right? So the shading is to the right. The x is the shade. You're shading what x is. Whenever we shade on a number line or a graph of any kind, you're always shading the x. And what is the x? The x is saying, hey, I'm greater than 7. I'm to the right of 7. Shade to the right of 7, and put an open dot because you can't be right on the 7. So there we go. Is that good? Okay, so this one, we got -4, like that. So there, notice the x is between two numbers, isn't it? X is between -4 and 6. So it's one of these two, first off. Everybody see that? X is between. So the shading is the x. So the shading is between -4 and 6. So it's either C or D. Which one is it? Well, next to -4, there's no equals bar. You can't be equal to -4. There's got to be a hole at -4. And you can be equal to 6. Solid dot at 6. It's D again. Does that make sense? Right? You can be equal to the 6. That's the bottom of an equal sign. So you can be solid at 6. You can be right on the 6. You can be equal to 6. But you cannot equal -4. So there's an open dot drilled out, missing at -4. Shade in between. So the x is the shading in between -4 and 6. So 8 minus 3x is greater than 3 minus 2x. Okay, so now we're going to solve a greater than, less than problem, but it's the same as solving an equal sign, basically, with only one small exception, which we'll see. But otherwise, just pretend it's an equals. It's basically the same thing. X is saying I want to be alone. You know, same stuff we've been doing a lot of. So try that one. Let me give you a second. Try that one. Do what it takes to solve for x there. What do you do when you have x on opposite sides? Get rid of one of them. So it doesn't really matter which one. Did you guys add 3x to both sides, or did you add 2x? I want to do what the majority did. There's a mix. Okay, maybe I'll do it both ways. So you could add 3x to both sides, for example, or you could add 2x to both sides. Either way is good. So I'll show both ways. You could do that. So over here, I'll show the other way. So over here, I'll show, if I have room, x minus 3x greater than 3 minus 2x. So the other way would be to add 2x to both. That's okay also. Okay, then what are you going to get? 8, here you're going to get plus x. Here you're going to get, oh, well, that's supposed to be 8. I changed the problem. There we go. Here you're going to get 8 minus x, and 3, right? So depending on how you did it, right, whether you added 3x to both sides or added 2x to both sides, they're both valid. Now, say you're working on this one. What would you do on this one to finish x and saying, I want to be alone? Subtract that 3, right? Subtract that 3. Boom, so this is 5, like that. Now on this one over here, same thing, x on this one, x is saying I want to be alone. So what do? Subtract that 8, right? Like that. And you get minus x greater than minus 5. Remember that? Let me bring it up here. Okay, good to there. Okay, so so that one's done. This one you would have one more step to do because you got to get rid of that minus sign, right? We've had that before. That's not a big new thing. How do we get rid of that minus sign? Divide by -1, huh? On both sides. Yeah. Now, here's where we have one difference between solving an equal sign problem and solving a greater than or less than kind of problem. Do you know, have you seen this before, that when you divide by a negative, you need to flip that symbol? The symbol needs to turn the other way when you divide by a negative. So in other words, this becomes x less than this symbol turns to be positive 5. Does that make sense there? So let me write a note about that. So when divide or multiply, actually, either. Divide or multiply. Right? Multiply and dividing rules always go together, don't they? By a negative, you must flip the symbol. So when you divide or multiply by a negative, you must flip the symbol. Right? So when you put a negative under the bar, you're dividing by a negative. You got to flip the symbol. Now, don't be confused with -8 here, for example. That wasn't dividing, was it? That was just subtracting. So I didn't have to flip the symbol. But right here, I put the -1 under the bar. When you divide by negative, you got to flip the symbol. So I flipped it, and there's the answer. Now, is this the same answer as this? Yeah, do you remember you can flip this whole thing around and it's saying the same thing. Hold on, did I just confuse you by talking about two different kinds of flipping? So this flipping was just the symbol. X and 5 stayed put. Just the symbol flipped, right? That's what I mean when you divide by a negative. When you divide by a -1, just the symbol in the middle flips, everybody else stays put. This was just flipping the entire statement, which you can do anytime you want. That always says the same thing. Do you see what the difference in what I'm talking about? I just flipped the entire statement because I just prefer having x on the left, like that. So notice they're saying the same thing in the end, aren't they? Either way, Exact same answer. X is less than 5. Good on that, so you would choose option B here, huh? Option B, X is less than 5. So choose the less than and put in the 5. Good on all that? Are we happy with all that? So, start with this one. So 6 minus 9y minus 2y less than 72. Try that one. Solve for y there. Give you a second on that one. We good with that? So 6 minus 11y, right? So minus 9y minus 2y. And then y is saying I want to be alone, so what do we do next? Subtract the 6, like that. So we're gone, so minus 11y less than, what's that? 66? Okay, and now what's the last step here? Divide by minus 11, right? And what does that mean we need to do? Right then, you're actually supposed to do it right then. Flip the symbol the other way because I divided by a negative, huh? So what do we get? Y is greater, and this is now positive over negative? Negative 6. Y greater than negative 6. Does that make sense on that? So just flip the symbol. Otherwise, it's just like solving equals problems. The only thing to remember, the only difference is if you divide by negative, flip the symbol. Otherwise, it's just like equals problems. No difference at all. One more on today's test. That one right there. How about x over 3 minus 1 less than or equal to 5/7. Here's the wall. All right, you know what to do. So what do we do on this one? Multiply through by 21. Common denominator, right? 3 and 7 both go into 21. Remember, you got to consider both denominators, all denominators. 3 and 7 go into 21. So the common denominator is 21. Multiply everybody by 21. 21, 21, 21. All right, y'all doing okay on that? So 21, 21, 21. Right on through like that. And then 3 goes into 21 7 times. Remember, you cross cancel and multiply what's left over. What's left over? 7x minus 21. And 7 goes into 21 3 times. What's left over? 3 times 5, 15. Is that good so far? No more fractions. Good to there. That's the most important step. Everybody good to there? I know you can all do the rest easy. Is that step okay? Does that make sense what I did there? Just cross canceling and multiplying what's left over, right? And then the rest I know is easy for you. Then you just add the 21 to both sides. That's gone. And we got 7x. That's equal to, what is that? 36. Last step is divide by 7. There it is. X is less than or equal to 36/7. It's kind of an ugly fraction answer. There we go. All right. Is that good? If you had enough math?